Well, hi. So I got a SkyBox system in May, and I've been playing with it. I'm like, oh man, this makes it really easy to do live shows. So I wrote my own show. I call it Superstorms and Dust Storms and Acid Rain. Oh my, a look at weather throughout our solar system. So it's about planetary weather. And I made it an augmented lesson. Oh, and I'm like, hey, I'm going to present this at eLIPS, and maybe I can get some hints for how to make this more interactive, because I love how, like with this system, it's easy for me to just do things on the fly. Like, you know, I'm doing a typical constellation show, and the kids ask me about meteor showers and asteroids. So I'm like, hey, do you want to fly to an asteroid? And so we just do, and we can, you know, and I love how live shows can, you know, you can switch things up and they change. And so I have an interactive show about the weather in the solar system that I'm going to present to you. So you guys are my audience, and oh, I use the whole Earth data set here. You know what? I'm going to share this one. All right. So it doesn't look exactly like this, but on my iPad mini, but in this augmented lesson, I've got buttons I can click to turn on different things. I have the words to say. I've got pictures that I can click on, and it'll just bring it up in the dome. It makes it really easy to present and so forth. Okay, so now I stop my share. So the solar system is full of interesting weather, but before we begin our flight through the solar system, I have a question for you. What is weather? It's SkyBox. It's a Digitalis.
Weather is what you get when you move someplace for the climate. Weather is what you wear, what you have in your wardrobe to wear when you go outside.
Snow is a type of weather.
It was a type of weather.
Atmospheric activity.
Yeah.
I have a good couple of winter jackets that I'm willing to part with. I got news from here in sunny Florida. Although if sunspot activity continues to be low, you never know. We might get a bit of a frost on the ground.
Good. Jenny gave me the answer that I'm looking for, like changes in the atmosphere, stuff changing in the atmosphere in the short term. Yeah, so it has to do, it's the state of the atmosphere. So I can also fly around with, oh, of course it decided to turn off for me, but so what I have up here on the dome screen right now is, oh, they turned on. So this is the Earth. Let's go back to our, where we're looking at the globe again instead of landing. Okay, here I've got the current clouds, and we can fly around. We can look at, okay, I've got rainfall. You can see how this, well, you guys got it. You know how so it's the atmosphere. So, oh, what do you think? Thank you, Jeff. What do you think the weather is? What have you heard about weather? Okay. I'm gonna clear all my data sets now. So what planet do you want to visit first? Where do you want to see the weather? All right, Mars is the first one I saw. So let's fly to Mars. I do have a fly to Mercury to talk about, that Mercury doesn't have an atmosphere, so Mercury doesn't have weather. But Mars has an atmosphere. Mars is the dusty planet. So it's got dust storms, and but not only that, these dust storms are runaway dust storms. They are so large that sometimes you'll get a single dust storm that will envelop the planet every 3 to 4 Martian years. And it was actually in a dust storm that we lost our Opportunity rover. And I have some movies that I can play with it. So this was in the a big 2018 dust storm. So you can see how big that is. So the dust in these storms extends more than 37 miles. They occur more frequently during the southern spring and summer. The wind speeds only get up to 60 miles an hour, but Mars doesn't have a very, since Mars has only 1% of the atmospheric pressure of Earth, winds on 60 miles per hour do not cause nearly as much damage as a similar wind on Earth. Now, I want to show you this picture. Look, this is as the dust storm is coming. It gets really dark. All right, I'm going to take that away and I'm going to pull up. So here's a picture looking at the sun as a dust storm is appearing, and you see how it gets really dark on the surface because of all that dust. And I've got some global images of Mars before and during a dust storm. You see all the features are all washed out because we don't, from the dust. Another thing we have are dust devils. So there are dust devils on Mars. And you can see them in this video. And actually, sometimes these dust devils come and they clear off the dust that accumulates on the solar panels. Because these dust particles are very small and they're slightly electrostatic, so they stick to surfaces like styrofoam packing peanuts. All right, I'm going to show you this one. These are dusty solar panels on Spirit. All right. Mars, Venus was the next one I saw. So let's fly to Venus. Venus is hot. I'm thinking one thing I can do is hand out my controller to an audience member and let them fly around the planets as once I fly to them. I like that. Christa Ingenuity needs to fly over them and dust them off. All right, look at all these clouds. So Venus is a terrestrial planet, but because of the thick atmosphere covered in clouds, it does somewhat look like a gas giant. At least it's kind of reminiscent. Now, the Soviet Union landed 10 probes on the surface of Venus, but even among the few that functioned after landing, the successes were short-lived. The longest survivor lasted 2 hours, the shortest 23 minutes. And here is a picture from the Venera 13, picture of the surface that we got in 1982. And here's a picture of the surface that we've seen from radar. And an artist impression of lightning on Venus. So Venus's atmosphere is one of extremes. So it's got the hottest surface in the solar system, apart from the sun itself, and it's even hotter than Mercury, as you know. So to outlive the short-lived Venera probes, your rambling sojourn on Venus would presumably include unimaginably strong insulation. Its temperature is pushed towards 900 degrees Fahrenheit. You would need an extremely thick, pressurized outer shell to avoid being crushed by the weight of the atmosphere, which would press down on you as if you were 0.6 miles or a kilometer deep in the ocean. The atmosphere is mostly carbon dioxide with clouds composed of sulfuric acid. And at the surface, the hot, high pressure carbon dioxide behaves in a corrosive fashion. It would not be a pleasant place to be. The atmosphere circles the planet in just 4 Earth days, causing winds in the atmosphere that move at more than 60 times the planet's rotational speed. So on Earth, the fastest winds only get to 10 to 20% of the rotational speed. But on the surface, the breeze barely reaches 6.3 miles per hour. The most amazing feature of weather on Venus is the acid rain. So these clouds, which obscure the surface, are made out of sulfuric acid and sulfur dioxide, so it rains sulfuric acid. But it's so hot on Venus that the rain evaporates before it gets to the surface. This lightning on Venus might be from the sulfuric acid droplets, which can be highly electrically charged, or it might be from volcanic eruptions. Okay, so we've been to, I think I saw Jupiter on the list. Jupiter. Yeah, let's fly to Jupiter.
2 minutes left, Christa.
All right. I'll just fly there and show you some of my pictures, and then see what else, read the comments and see what people have. So for Jupiter, I've got a picture of our great red spot, that animation. I talk about, I've got a size comparison to Earth. I've got a diagram that shows the winds, the bands, the stripes move in different directions. And I've got a, you can see it in this animation here, how each stripe flows a different way. Okay, so, and we just fly around, and I say at the end, thank you for coming. I hope you enjoyed this whirlwind tour of weather in our solar system. And yeah, I'm planning on sharing this. I have to make a few more changes to get the scripts to work right, but I am planning on sharing it on the community site. Thanks.
What kind of reactions did you have from kids when you were doing this, from your audience?
I haven't had the chance to do it in front of a live audience and really gauge reactions yet.
Christa, that was awesome.
How hard was it to write the augmented programming?
So I just downloaded the sample one and looked through it, and actually here, and I just went through and looked at the examples. I'm like, okay, so this paragraph is, or where it says narration, that's where I want to put my text. And oh, here's a picture. So I just kind of used their sample as a template. I went through and copied and changed the things that, to match my content. It wasn't too hard.
But we have a grant currently in consideration to hopefully get a new digitalis, and I'll probably be the one in charge of writing the augmented scripts. So I'm wondering how much learning I have ahead of me.
Wouldn't it be better to have white characters on top of a black page?
I have, there it went. So when it shows up on my screen, it's red characters on a black screen. Yeah. But I couldn't figure out how to show this on Zoom. So I just showed the one that yeah.
Thanks.
I've got I'm sharing an augmented lesson right here on my screen, just so you can see it. Maybe hit a button with an image, then it throws it up in your dome. Or if you go to a script, like this one here, this flies your system above Earth orbit, for instance. But a lot of these things you can just do live, but the augmented lessons is a nice way. If you do something like Christa, where you've got a whole bunch of different photos and video that you can throw up there, it's worth it to do the augmented lesson, so it's just easier.
And then it's all in one place instead of having to, so I'm not so good at switching. It takes me a while to switch tabs and okay, now I have to,
Yeah. And that way you can give it to other people too, because not everyone's going to have all the content knowledge of a Christa. So it's easier to pass off to other people.